Hello everyone. What we are going to do for today's class is basically having some exercise for a while, just to let you familiar with the differentiation rules and some difficult questions. So I have prepared, I think, three or four pages on today's notes. And also I will put this later on the class notes for your exercise and practice, and also with other additional practices as well. Okay, I'll try to prepare by this week. So I hope next week. Okay, next week. Maybe let me write first what which we expect on next. Maybe later I will inform you about the makeup class and what should you do next week. Okay. So maybe you could try any suggestion which it's too sensitive. Okay. Any suggestions? Which one should we cover first? We will start from the simple one. Okay. Let me pick some numbers. So 9 maybe, and 13 and 14. Just to let you know what is the expectations. Maybe the 15. And what else? 23, 25. Okay, maybe that first. Actually, it has 52 questions, but I will just take the half part first and give you another half, maybe for your practice later on. Okay. So let's try this 1, 2, 4, 6 questions. Okay. But I think maybe you are not covering 6, maybe only 3 to 4. But I hope you can continue. Okay, continue. So the idea is to take the first derivative for all these expressions. And there are some assumptions that you need to be familiar with. Of all the calculus 1, the assumption should be the function should be one variable. Okay? And then, especially if you see like a function like different variables, you need to just realize that that's the same thing with our regular x or our default symbols x. Okay? Like you have t, you have theta, but they are the same thing, single variable. Okay. You can try that first. Try it maybe from the simple one, number 9. Or if you want to try other numbers, it's okay. It's okay. But it's the one that I probably would suggest you to do. Okay, yeah, this is down. Okay, by the way, I have checked all the, like, based on your quiz score, my suggestion is to take the tutoring session But actually, it's up to you if you want to join the tutoring or not. I suggested some tutors. I think you can check your email. Of course, university email, okay? Not your Gmail. I don't know your Gmail or other email, okay? Check your university email. And I also CC the tutor. Okay? And that's mostly for international students. But for local students, if you want to join them for tutor, you can join too. You can check with them. I will give the details later on Moodle, okay, if you want to join. You can also propose to your senior, okay, GDET, maybe second year or third year. Because I also teach them. Maybe I know someone who maybe can teach you, and maybe he can also maybe offering his time to teach. But if the student doesn't want, then maybe the only option you can join with the international student. But of course, it will be in English. So if you with your senior, you can just he can teach you in Chinese, and it's very easy for your friends. Okay, please try 2 or 3 questions first from all this number. The one that has circle, green circle. Okay. You can try number 9, and then number 13 and 14. I hope you see the difference. And you see the difference and how we are able to solve this first derivative. Okay. Can you do that? Yeah. You can choose any physical one. Okay, expectations. Okay, expectations. So, if you want to move forward, sometimes you can check how much time you need to solve problems. For problems like number 9, you need to solve this at least under 30 seconds, okay? Or 20 seconds. Perhaps 10 seconds, okay, 10 seconds. I'm serious, 10 seconds. Okay. If not, then you need to be familiar with that. Okay? That's my suggestion. Because the square root functions will appear a lot in calculus 2, and then you're still using the same techniques from calculus 1. So if you're not familiar with, then you need to try your best. Okay? The grand design for this square root, okay, I think I mentioned before, is basically whenever you have y equals square root of x, okay, this derivative is let me write it clearer. Is this, right? So based on these rules, then this part here, and remember you need to multiply with the chain rule. The chain rule here, since it's just x, so let me write completely with the chain rule here. Okay. So this is actually like this, and then d dx of x. Since the d dx of x is just 1, then we can just write this. And do the same thing with this. The same thing. So we can write okay, do you get it? Okay, let me give you the middle steps. So the middle steps will be or let me write 1 and then d dx of 5x plus 1. Okay? I'm trying to leverage your levels. I'm trying to push it. So I hope you can get along with it. Okay? Because if you are on this, if we are the same level as we before, then the future will be very difficult. So I'm trying my best to leverage your level. Okay. If you feel intimidated by the functions, but you know the chain rule, you know the chain rule very well. Because sometimes, I think I also have this kind of problem when I was still a student and trying to solve some exam. I also have some problem, and then I tried to figure it out how to remove my either anxiety or any nervous when I'm doing exam. What I did is this 5x plus 1, it can be any function, right? It can be polynomial, it can be any complicated function. But you can simply just change this 5x plus 1, just take A or B. So any A or B, when you take the chain rule, for example, if I take this as A, and A is just like a function. Okay, let's say we are here, Y, and then just take A like that. Any symbols. Actually, you can just change not A, and you define something like, maybe like a cat like this. It's very cute, right? But what you need to do is, every time you take the derivative, you take the outside one. Okay? You take the outside one, and write again itself, right? And then try to differentiate the one that is inside. Okay? So you can change to every symbols you want. It is for your practice, Because sometimes you see the question first, the function, and then it feels, oh, it's so complicated. Every time you solve something in mathematics, in calculus especially, do not rush. Okay? Like you want to get final results directly. Sometimes it doesn't work. Okay? Sometimes it makes your mind will be difficult to process, okay? Because you need time. And the process in mathematics is sometimes like take slowly, layer by layer. Okay? Just like the chain rule. It's okay if you are slow, but remember the steps. Okay? When you are doing it correctly, then you can make it faster when you understand the concept. Okay? Okay, that's number 9. And see number 13 and 14. Okay? Number 13, number 14. It seems similar, right? The cosine theta squared, and the other one is cosine squared, okay? Which means that it's a different function, right? So the first one is the theta squared is inside. The other one is the cosine theta that is inside. You get it? So if you take this number 13, let me write on here. So number 13, the function squared. So we know that this is a cosine function. Take derivative. What's the derivative of cosine? Maybe I didn't give you a complete derivative last time. So let me just give you very quickly right here. So if you have an f of x, if it is sine x, it will give you cosine. Okay. But if you have a cosine, it will give you negative sign. The sine and cosine, since they are getting repeated every time we have some cycles, it's very interesting And later I will tell you what's interesting about the cycles. But for now, let's just concentrate here. So we have cosine x. The first derivative is negative sign. Okay. So negative sign is our derivative of cosine. Now the chain rule said we take derivative of the outside, which is cosine, and we write negative sign. And everything that is inside, just write them. This I did with the cat. Okay. So take derivative and negative sign. Just write them like that, and then take derivative of this theta squared, which gives you negative 2 theta sine theta squared. Okay. There are one more. Okay, so we have the sine, cosine. We have another one, usually that is important in trigonometry, is tangent. Okay. So how about tangent? Let me write here. Let's think about tangent first. Okay, what is the first derivative of tangent? Maybe someone already know. Yes, secant squared. Okay. Now, how to get the secant squared? Okay. The best way, or maybe my suggestions, is taking the sine x over cosine x. Okay. And then take the. Let me use different color. So take the derivative of the sine x over cosine x. Okay, remember, fg, f prime g, g prime f. Okay. So f prime is cosine, g is cosine, minus g prime is negative sine, right? So this will be sine and negative sine, which in turn it gives you cosine squared x plus sine squared x divided by cosine squared x, which the top one is 1, right? Over cosine squared x, or you could directly write the secant squared. So hx tangent x, the h prime x is secant squared x. Okay. Few examples on trigonometric functions that perhaps easily if you know beforehand. Okay. And I think the other part, like I think in your textbook they mentioned also the cosecant, the cotangent, blah blah blah. I don't think that is important. As long as you know this one, you know the other one as well. So no need to memorize a lot. Okay? Just a few things that you need to keep in mind as your fundamentals. From there you can derive all the trigonometry. Okay? Okay, any questions
Can you
first?
explain the sine and cosine one again? Sine, cosine. The last one you did in the class.
This one?
Yeah, can you just explain that again?
This one?
Yeah.
Okay. Okay. This one is from the quotient rule. The quotient rule, I mean, maybe I don't know what here, get the quotient rule, just to let you know how to do the quotient rule. The quotient rules is basically, let's say this is all f over g, and f also g also up. They are both function of x. Okay. So this is g squared. This is f prime g minus g prime f. Prime means it's the first derivative. Oh, wait. So simply I'm just doing this for this part, which means that this is f, this is g, so f prime, the sine derived becomes cosine, multiply with cosine becomes this, and minus is supposed to be g prime is cosine, is minus sine here, and then f is sine, so sine minus sine has become positive sine squared. Okay. So cos squared plus sine squared is 1, and then it's becoming 1 over cosine squared, which is secant squared. Okay. Okay, any other questions? Okay, if you're still wondering the trigonometric part, it means that you need to have some background in trigonometry, okay? Which I cannot provide all in this part. But some summary I will provide. Okay. Okay, another one is the number 14. So cosine theta squared and now cosine squared. Now we can imagine this as it's cosine theta, but within a square like that. Okay. So if I write like this, it's clear that the inside was the cosine theta, and the outside function is the square, right? And simply, if you are estimating by the inside function, you can change with everything. You can change with any symbols, or even you draw a cat or dogs or anything between. So you can just use that, and then what we did is we just take the outside. Right? So we take 2, and then it's become 1, right? So 2 something something 1, okay? And then multiply with the chain rule, multiply with the derivative of the inside. Okay? So this will be g prime theta would be 2 cosine theta, and then multiply, let me write d dx of cosine theta, which resulting in the negative sign. So this will be negative 2 sine theta cosine theta, or negative sine 2 theta. Okay, maybe the last one for this page is the number 15. Okay. The number, all numbers, I think you can try by your own. Okay, you can practice. So number 15. Okay, we have the e. Okay. E with power of x squared minus x. X squared minus x. Okay, remember the e is another function that is quite unique, because every time you derive, you will see another e, right? It will express with another e. And this is quite useful, and because of this usefulness, most of simulations, like from I think anything that's related to differential equations, like any physics phenomenon or everything that can be simulated by differentials, they are usually using E for solution, because it's really practice, because you can derive and integrate, and then it's still E. Okay, so, but now we have E and also the chain rule, right? So what's happened with this? So what we are going to see is this expression again, but we need to multiply with this chain rule. So you could imagine we have E with power of x, and then we have another function which is x squared minus x. So x squared minus x will put inside the x inside the e power of x, right? So we can imagine, let me write maybe here, 15. So let me write here, gx is
E. Okay, let's start from there. So we can think that this is e to the x, and then we have another function that is x squared minus x, and this is going to be inside
That x, right? So what's happened now? Okay. We know that these expressions will result in the same e to the x. So we just rewrite this again. Okay. So
the g prime x will be, let's just write this all over the place, and then d dx of the x squared minus x. Okay.
yes. The red one. This is just an explanation.
No, I just read it again.
No. Do you understand why I'm writing
I
that?
understand.
Yeah. What's this?
X squared minus x is x.
Yeah. You can imagine this coming from two functions.
Yeah.
This and this.
Yeah.
This going to be inside here. Okay? Get it? Okay.
Okay, this is 2x minus 1 multiply with this. Okay.
So when you find the patterns, it's actually becoming much more faster. Right? Do you agree? Or you still have found this a little bit slow for you? Or do you need more practice? Do you agree? You can see the pattern or no? Yeah, I mean from every type of function. Do you see the pattern now? Do you see the pattern? Okay. So sometimes when you study, it's better to test yourself. Okay? If you study but you just see your notes, oh, what is this? You take the time, oh, I forget this, and you see the notes again, it will not work. It will not work. You will not be able to solve that question. Try sometime, do that on your own without looking at your notes. Take for maybe 10 minutes or 15 minutes. Take some numbers, maybe 5, like random questions, and then how many questions you can get. That's how you can leverage your limit.
No, another question.
Yes.
That question.
Hmm?
Is that one another application of the chain rule?
Yes. Chain rule, yeah. This is chain rule, yeah.
2x minus 1 times e to x squared minus x. That's the derivative.
Yes.
No?
Yes. What do you expect? Done. Why you complicate your own life? Done. Finish. Easy, right? You think easy? Easy, right? Please tell me easy, right?
Can you explain why specifically 2x
From here. Okay? So if you write it in a correct way, step by step, and you understand how did that happen, like slowly you are getting better, and you will take these questions like just like eating bread or something. It will be very easy, and you can do it in your mind. No need to write. Okay? I hope you can get it. Okay? If not, then I'm not sure how to help. Okay?
So this is the same.
Yes. No. All the same. All the same. We just focus on two things: outside function, inside function. Okay, so all the chain rule will be focused on at least two functions. Okay? At least two functions that is going to be composed. The outside function and the inside function. Whenever we found the pattern, which one is inside, then we can derive all type of functions. Okay? For example, this e, we know that we can separate this become two. Okay? E to the x and x squared minus x. So you can imagine that x squared minus x replacing this x. Okay? So the outside function is the e, right? So we differentiate the whole e becomes like this. But don't forget to multiply the chain rule. The chain rule is the inside function. Okay. Now this is one, some examples that I show you that is quite simple. Okay. But for other functions that might happen in your exam, it's not as simple as this. Okay. Sometimes this one is another chain rule. Okay. So you need to have like you cut the onion, okay, like cutting onions. Take one time. Maybe the inside is having another inside. Okay. So that's okay. So if this is still having another inside, then maybe you can derive this and then multiply with another chain rule. And you can do it for many functions as well. Okay, so like slowly, step 1, step 2, step 3, and you can get your final result.
Okay, so I will leave all the questions to you, so you can check them out. And I think the one that I'm circling here is interesting. Okay. The other one, simple but too long to write, but I think still okay. I think you can do it. Like number 21 is just normal. You can take derivative 3 to the front and then chain rule, multiply by 4, so 12, 4x plus 5 squared, x squared minus 2x plus 5 is 4. And you can do it, right? You can do it, I think it's simple, but you need to write a little bit long. Okay. Or maybe you can also try this exponent. Okay? See that if you remember how to solve this. But I think I will leave all the other questions to you, okay, or to your TS session. Okay? And I will go to the other type of questions.
Maybe this is too difficult. Maybe I will tell you later. Okay.
Maybe go to the next one first, okay? Let me check.
I think number 5, 56. Okay, 56. Okay. It's a little bit complicated.
Or maybe let me look up one simple question first before this one, okay? I think I forgot to mention the one simple questions. So number 56 is actually about the tangent line. So the tangent line is, I think, a typical question that it must be in your exam. If not, then maybe any relation with that question still taking the first derivative and then finding the tangent line. Okay, let me write a simple question before doing this. Okay, let me write here on the down here. Maybe. Okay. This one will be find an equation of tangent line to the curve y x plus sine x at point P and P, x equal P, y equal P. Okay, number, okay. So at least
Because it's related to trigonometry, I hope you are more and more familiar to trigonometry. Okay? Sine, cosine, and then it's expressed in different value. For example, like the special value from 0 to 2 pi. Special value usually 0, pi over 6, pi over 3, pi over 4, pi over 4, pi over 3, pi over 2, and all the repetitions. Okay? And you can put into the graph. Okay? Hmm? It is at the point.
So you need to find the tangent at those points. Maybe let me write here at point. Okay, at point. Yeah, it's pi.
Pi. Okay? It seems like someone crying. Okay? It doesn't get the results. Okay, but this is a typical question. Okay? A typical question. Remember, what is tangent? If you draw a curve, what is tangent? Yeah. A function?
Intersects the function at only 1 point.
Intersect a function only 1 point. But what is exactly that?
Degree.
Yes, slope. Yes, slope at that point. Slope at that point. So it means that our first derivative, I think as I also mentioned, I think many times, is the tangent. The slope is the tangent. Or you could say the slope is the first derivative. Okay. So if we take the first derivative of the curve, and if we put the point, we put the x, since this is only x, so we put pi inside the first derivative, that will be our value of slope value, right? Okay. So let's try to take that. Okay.
So the first derivative is 1 plus cosine x, right? Now what's next is we take, so let me write maybe here, so add pi or x equal pi, then y prime is 1 plus cosine pi. What is cosine pi? It's going down, right? Going down. So it's what? Minus 1, yeah. So this will be minus 1, this will be 0. So
What's the deal? What's happened when the y prime equals 0? Yes, it's horizontal line. It's the line, right? Without any value of the slope, so we don't have the degree of the steep, right? So it's just horizontal, right?
So if we want to write the line equations, I hope you still remember. So let me write. I think you get this from junior high school, right? Or maybe high school. But I get it from junior high, if I'm not mistaken. And then what is y1 and the x1? This is basically our point that we are going to input. So this is pi, right? And this is pi. And the m, the gradient, the slope is 0. So this is 0. So basically, we can just say that, okay, this will be equal pi. And this will be our line,
Our tangent line, which is the horizontal tangent. Actually, I would like to start from like proving the chain rule, but I think I will give you as additional videos. I think this will be more important for you to get familiar with the functions first. Okay, maybe I will give you one more something similar to this, but different functions. Okay, and to see how you can take time to solve that before we move to this 56, 57. Okay, I hope I can get to the next page, right? Okay. Okay. So find equation of tangent line to the curve at the given point. I will give you two conditions. So question number 1, if the curve is y and the point is 2, 3, and the second curve is and this is, I think, also good exercise for the previous function that we did, the first derivative. Okay, try to take some couple of minutes, maybe 3, maybe until the break. You can take this. Which means that you need to find for both questions, for both curves, the equation of the tangent line. Okay? And then after we finish this part, we can move to the question before, the 56 and 57, which quite, if you see like from the surface, quite intimidating.
Announcement, like next week your TA class will be earlier from 1:20 to 3:10, so 2-hour TA class. But for the class on 5th, no class, okay? No class. And then we have a makeup class on 10. This is 10, 20 to 12. This is at our class. Okay. Okay, so next week your TA class will be 2 hours, and hopefully she can give you some more practices about the techniques and more variety of questions, so that you can have more practice. Okay, and no class on 5th, and we have makeup class on 21, okay? From 10:20 to 12:10. Okay, I hope you can join the 21, okay? Because I think the end of October will be the first exam, your midterm. Around, maybe if we need more time, maybe we can postpone to the next week. Okay? But for now, let's say we are going to set our goal to the end of the October. Okay? But we still maybe need 1 more or 2 more class, then maybe we postpone to the next week. Okay? So that you may have more TA sessions or more tutorial sessions. Okay, anyway, your TA, you can request actually for more hours, but you need to know like how many of you need more, so that TA can check the schedule and then borrow another class, the classroom. So maybe she may ask, and if you need, please let her know, and she can like arrange for another PA session. Okay, back to the question here. Okay, I think some already okay. So let me put the announcement down here. Oh, content outside the page. Okay, number one, y prime is 3x squared over 2, 1 plus x cubed, right? Got it? You already correct. The x squared from the 1 plus x cubed. Okay? Yeah. Your way is correct. Okay? You just need to add more line. Okay? And then we take at x equal to, this will be 12, 2, and then 1 plus 8, so it's 9. So 3, 2, 6, and then it's 2. So the slope is 2, which means that we, let me write to make it okay. So add 2, 3. The line equation will be 2x minus 2. So this is 2x minus 1, right? Okay, number 2, y is x e with power of negative x squared, and we need to check at 0, 0. So what's happened with this question is, first we need to let me resize this to make more space. Maybe here. Okay, I think we have more space now. So how to make our y prime? Remember, if you can see that the whole function here is basically a composition of more than one function. Let's say x is 1, x is f, and e is the second function. So we can think this is like, this is f, this is g. Okay. So every time you have the fg, then your y prime is f prime g plus g prime. Okay, and then write all of the results. So f prime is just 1. So g is e, and then plus f is x, and g prime. Okay. Okay. Let me write here. So ddx of e with power of negative x squared. Remember, we did this kind of function before. So the outside function is e, still the same, right? And then multiply with the chain rule, okay, which is negative 2x. That's for g prime. So we are going to multiply f, which is x, and then the whole thing on here is g prime. So x multiplied with that, we get this become negative 2 x squared e. Okay, or we can simplify and factorize the e. It's become 1 minus 2x squared. Okay, do you need more steps to get the context, or do you get my method? Okay. And then at the 0, 0, so we put 0, so we put maybe right here. At x equals 0, so whenever you see this line here, it means you are going to evaluate at this number. Okay, plug in inside, plug in the x. Okay, we put x equals 0. E becomes, e with power 0 is 1, so 1, and then 1 minus 0, so it's just 1, right? Let me just write y prime at x equals 0 is 1. Okay, and the equation of the tangent line becomes y, so at 0, 0, so y becomes equal to 1, and then this will be x minus 0, so I think this is just at y equal x. That's the answer. Okay. This one or the product? This one or this one? Okay, let me add more space. Okay, let me add more space to see where does it come from. Okay, it's actually from here. Let me write. So this is E. let me write plus first, okay, and then let me take bracket like that. So G prime is E, and then X is just for F. This is F prime G. This is G prime F. Okay.
F prime is just X derived 1 here. G, okay, the same. The second one, we already have G prime over here. Okay, G prime. And then multiply again with F. Okay, F prime G, G prime. Okay. My expectations actually for at least like 1 month, around 1 month for dealing with derivatives, you'll be able to skip some process and directly go here. I hope. If not, but please just take the concept clearly. You can still doing this and check confirm by yourself. Okay, I hope you get the concept. Yeah, you get the concept. But my expectation is, of course, you get this there. But don't rush to the final result. Okay? Like you need to go fast, but do not like rush.
Okay, so that's number 2. Okay, so as long as you are taking times to practice and try your own limit. Okay, try your own limit, like increasing your level. Okay. I hope you can get the benefits. Like my suggestion at the early of the class, I suggest you to check your own level of understanding. Take several examples. Okay, you can check your books or maybe check my question. Take your time to solve that by yourself, and try not to look at your notes. Give times, maybe 10 minutes, 15 minutes. Check your times, and then if you can, like maybe at the beginning, maybe from 5 questions, maybe you can only do 1 or 2, or maybe not at all. That's okay. As long as you are trying to keep improving, okay? Keep improving, and check again, and I think you can do it like with your friends, like pairing, or maybe 3 students, like they give each other students questions. Okay? So it's kind of like random. And to make sure that everyone gets random questions. So you could also try doing that as well. Okay? And for students who get my email, of course you need to check your NTUST email about tutor. Please check that out. Okay? And for local students, if you need one, the one that already prepared is for the international one, but you can join if you want. But if you prefer with the local students, either you find your senior by yourself, or I will ask them, okay, who can teach you, okay. But if they are not willing to teach you, then the only way is to join with the international student. You will use English, but I believe for mathematics you could still join. Okay, I know like you can understand the basic English. I think still okay. Okay, now let's try this one. Okay, let me cut and okay, we have the like having a parallel lines. So try number 56 first. Okay. So first, maybe reading the question, whether we understand or not. So, okay, this is your curve. Okay, this is your curve. The same questions. Find equation of the tangent line to the curve. This curve. Okay. But now it doesn't give you any points. But it gives you another line. It gives you another line, which is this line. X minus 2y equal to. Okay, now we have some terms here, keywords, parallel. Yeah, what's meaning parallel?
Because it's the slope.
Yes, it has the same slope, which means like it's like if the line like this, then the other line is similar, similar slope. Okay, that's parallel. The other condition that might appear in exam usually, if not parallel, then perpendicular or like this. It's like ultraman. Yeah, like this. Okay, perpendicular. Okay, now the idea then, from this parallel line, what will be the slope? What will be the slope? So of course we need to make it into the y mx plus c. Right? Yeah, 1 over 2. It seems like 1 over 2, right? Because it's 2y. So we need to make in the y equal mx plus c. Okay? So that's how you do it. So you get the slope from here, which is you need to make it equal to the slope when we calculate the derivative. Okay? So there will be a little bit observation and analysis within the questions. And of course, within the questions also, the first thing that you might do is you can first derive. Okay, maybe this takes time because it has the rational form. Okay. Okay. So I think you could try first. See, it's a little bit like it's forced you to think. Okay? It's forced you to think. It's not like just compute and then the numbers comes out. Okay? And my clue is maybe there will be some possibility, and you can also write those possibilities. What will be happening? What is the line equation? Maybe it will have several lines. Probably. Okay. So first, maybe let's try to find the first derivative. Okay. So let me write here that y is x minus 1, x plus 1. Okay. Now we have the quotient form, which is this is f, this is g. Okay. And then if you have y prime, let me just write with in terms f and g. F prime g minus g prime f over g squared. Okay. Maybe it's better you to memorize, but not too much. Okay? Maybe just some fundamentals that you need to know beforehand. So then we can rewrite this. So y prime becomes, let me write the line, x plus 1 squared for the g, and then f prime is 1, and then g is x plus 1. Or maybe let me write with 1, so you know why we get 1. Okay. And then minus another 1, and then x minus 1. And then maybe to make sure you avoid like sign value, maybe add another bracket, okay, just to make sure. It has a lot of brackets, but sometimes it will be really helpful. Okay. So we try to take this. So this is x plus 1 minus x minus 1. So x minus x is 0. So 1 minus minus 1 is 2. So it's 2 over x plus 1 and then squared. Okay, now this is actually at some point this will be our slope, right? Now we get the slope from the parallel line here, which is x minus 2 equal to. The left right here, so y prime is parallel, or maybe let me write maybe slope of y is parallel to x minus 2y equal to. Okay. Now we can rewrite this to y x minus 2, or y is half x minus 1. Okay. Now suppose, to get you clear understanding, suppose the point that we are going to look at when the slope is happening let's say the point is, let's say, x equal a, or equal any variables you want. So the y prime at x equal a is 2 over a plus 1 squared, right? And the whole thing need to be equal with the slope in the parallel. So the slope, so let me write here. So the slope is 1 over 2. So it need to make sure that it's equal to this 1 over 2. Okay? So we need to solve this and find what is a. Okay? So we get a plus 1 squared equal 4. So take the square root, both sides, to get a plus 1. And remember, because it's squared, we can get plus minus. Okay, so perhaps we can set this into some possibility. Okay, some answers. So a can be 1, or a can be -3. Okay, so it can be -2 and 2, right? Okay, now for a equal 1, so for a equal 1, let's write the y. What is y? So y is, what is the question? Curve? Yeah. So x minus 1 over x plus 1. So for a equal 1, so y 1, this is equal 0, right? And then for a, what is the second one? -3. Then y, or maybe let me write. Y -3 is, what is that? -4, -2, 2, right? And then we can plug in into our equation. So y minus 0 equal half x minus 1. So this is the first one. The second one will be y minus 2 half x plus 3. Okay. This you can write as this one. And the second one you can write 3 over 2 plus 2. What is 3 over 2 plus 2? 4 plus 3, 7. Right? 7. Okay. Okay, that's the line equation. So we have 2 line equations. Okay, I think you need to have some time to process this. Okay, any questions? Or you are too confused to ask the question? But it's quite interesting. Okay? This is, I think, a quite typical exam question. Any questions? Any questions? Okay, let me emphasize what we did here. Okay, let me reprocess in what happened in the process. Okay. Okay, the first one. Okay, I think it's okay, right? We find the first derivative, no problem here, right? Or do you still have problem with this one? The finding the first derivative? Okay, no raising hand, so it means that, okay, we're done here. Now the second one is from the parallel line. Okay? So the parallel line, we get the slope, okay? And the question say that the slope is parallel, which means they have the same slope, okay? Now, okay, to make sure that we understand the question, so I'm taking the x equal a. But usually if you understand the question, you can directly just write x and finding which x is, okay? But this is just to let you know what is the context. So the context is, okay, let's say it's on x equal a. So we put x equal a here and then evaluate. Okay? And it needs to force that it needs to be equal to the half. So we solve this a little bit. Okay, this simplifying the algebra. And we find that there are 2 possibilities. Okay? Because of the square here. We have 2 possibilities. And then we try those possibilities, okay? When a equal 1 and when a equal -3, alright? So a is 1, a -3. So we put 1 and -3 inside our functions. Okay, for a equal 1, okay, we put here, okay, 0. So we have 1, 0, that's our point. And we have the other one, which is -3 and 2. Okay, that's our point. And now we put back our point inside the line equations with the slope equal 1 over 2. So we get these 2 line equations. Okay? So there's 3 steps. Okay? 3 steps to process. First is finding the derivative. Okay? The second one is to look at the parallel line, which is described with the second statement. And then the third part is finding the equation, finding the line equations. Okay? Okay.
Do we now put A back into
The first one?
This one?
equation we got when we have we made x equals A?
You mean this?
I'm saying after we get our 2 A values,
Yeah, here.
yeah, do we put it back into the same equation or the first?
What do you think?
That's what I'm trying to figure out.
Yeah, what do you think? I'm asking. What is our function? Yeah, the first one. The first one. We need to find equation of tangent line from the curve. Of course, we put the curve. Show the curve, okay? To put back to the first original curve. Okay? So that's why we put here. Okay? This original curve. Okay.
What's your version?
Okay. Okay. I see some of you taking notes. It's okay. I will put the notes, all the notes here into the Moodle later, and you can check and maybe you solve by yourself, okay, without looking at my notes. Okay. Number 57, I will leave it to you, okay? I hope you get it. After some time, I will also, hopefully I can record some videos about this. Maybe tomorrow I will prepare and then let you know later. The next one is yes. Okay. Number 65, 66 is the same, similar, finding the tangent line, blah, 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 okay, but with variety and variety conditions. So I will leave number 65, 66 for you, okay? You could try, okay? Because sometimes when I say I leave this to you, you didn't do anything. Okay? Please try, okay? Try. Do not depend on your friends, okay? Your friends also confused. So don't depend on your friends. You makes the burden bigger. Okay? Try yourself. Okay? Maybe number 67. Okay, 67. 66. Same. Yeah. What will be the slope? Yes. You know that. Yeah. I'll leave that for you. Okay, number 67. 67. Okay. 67. I think we can do it really quick, right? Or no? Okay. So for number 67, I think it's quite obvious. Okay? It's giving you the composite function, so f of g of x. So what you need to do is you focus on this part. Okay? Focus on the structure of the function. Do not focus on this number. Okay? Do not focus on the number. Focus on this part first. This is the capital F. Okay? So you need to find what f prime, the capital F prime. So before trying to look at the number and count and compute, which is if you're doing that you will be getting wrong answer. Look here. What will be the first derivative of this? Write that down first without putting any numbers inside. After you get the structure, which is I think very similar to what I've taught before. And then after that, we put all the numbers which equal to 5. Okay? Okay, try first. So focus on the capital F. I think if you follow the chain rule, follow the compositions, eventually you will get the answer. After you get the structure correct, then you put the numbers. And you can confirm the numbers on the question. Which one is which? Okay, I think this is very similar to what we have done in chain rule as in general. So if we take the first derivative, we take this, right? And write this, right? Just like you did before, right? Okay. And what's next?
Okay, we just plug in the number. Okay, we get 5 here in the question, so we put 5 inside. 5, 5, 5, and one by one you can check whether you get the number or not. And then you can just multiply, and that's it. Okay?
So we take 5 here. So f prime g of 5, and then g prime 5. G prime 5 is 6 from here. And then g of 5 is, where is g of 5? Oh, here. -2, so -2. So we get f prime -2, g prime 5, which is 6, multiply. So f prime -2 is 4. So this is 4. So 4 multiplied 6 is 24. Okay? Okay, 24. Okay. Hmm?
4 goes from here. Okay, get it? And the other number is to confuse you.
I know.
That's why I'm saying don't look the numbers first.
And what we should look at? I know the last part is and is 5.
Yeah,
And
yeah.
the version of 5.
Yeah.
So then we just replace every single number.
Yeah. Perhaps the other numbers is to confuse you because it is expecting you to fail in this part. Maybe you will get the other number.
Okay, let me check how many questions do you still have. Oh, we have another one that is interesting. But since I think we don't have much time, so I think let's just
Solve the 68 before I change the topic to another question. So 68 it's going to be a little bit similar. It's still chain rule. Okay. Whenever you fix on the concept, okay, you understand the concept. Okay. The inside function, outside functions. Okay, and then in the whole calculus, in the whole mathematics, you are consistent with that concept. Whenever the question is trying to intimidate you, you will still be able to solve that. Okay? So you can actually conquer the questions, and okay, maybe when you see the questions, maybe you can smile and okay, I can do it. And sometimes maybe you cry. Okay, please. I'm trying to encourage you. Okay, because actually when you see the patterns, like at the early classes, I'm showing that it can be done like really fast. Okay, when you see like how much it can be done, okay? It can be really fast. But if you cannot see the pattern and you are sticking to memorizing the whole thing, that will be very difficult. Because like a computer. The computer has a RAM, right? And it has the storage memory. Your RAM may be limited, but your memory has a lot of spaces, right? But sometimes you are difficult to find which one that I need to take. And I think the flexibility on how using your mind is similar to your RAM. So it's, I think, important for learning any related course that is in mathematics. Either a simple computation or maybe advanced computations. The more flexible your mind has, I think you get more logic. You have more common sense. Okay, I think let me go quickly here before we end our course. So hx is this one, right?
And then h prime x is, let me go quickly now, it's going to be and then multiply with, okay, and then this part becomes 4 plus 3 f of x, and this part becomes 4 plus no, 4 becomes 0, 3f of x, 3f prime x. And then the question is h prime 1. We put 1 inside. This 2 is outside here. Okay, 2. 4 plus 3f1, 3f prime 1. Okay. So what is the f1 is 7. So this one is 7, f prime 1 is 4. So it's become 7, 3, 21 plus 4, 25 is 5, 2, 5 is 10. So 1 over 10, 3, 4 is 12. So it's 6 over 5. Done.
Okay. I'm trying to let you know that you can do it too, okay? You can do it, okay? Having more exercise practice, see the patterns, okay? Okay, anyway.
Can we go back to the question?
Question is number 68, okay? Number 68. Okay, I have a post test. I prepare a simple question. I hope you can all try. Okay. But since we have only around 5 to 6 minutes, so please join the post test first, and later you can check the Moodle for the whole notes. Okay. So let's move to. Okay, sorry if you are still taking the notes. Okay.
Use the website and write your name with your student ID, okay? Phone. Ah. Anyone has a okay. I'm really sorry if you okay, try your best. But if anyone cannot join because there's no device, let me know. Okay. You can write in the paper, okay, and then you can check the results later. Okay, and let me know whether you attend by chat in Moodle. Okay.
Let me know if you attend this class. Okay, I think we can start. Oh. Okay. Okay. No.
I mean, who doesn't join? You can chat.
Okay, I think we can start, right?
Oh, wait.
We can start.
No.
Okay, I think start. Okay, start. It's only 1 minute.
If it takes through, then if it takes fast,
Okay. It's false. False. It's false. Okay.
I think we did some exercise right at the beginning of the class. And you will see some choices. If anyone has still some trouble joining this, let me know. Maybe I need to check.
Okay, so I think that's it for today's class. See you next 2 weeks, okay, because next week I will not be here. Okay. Huh? Oh, okay, okay. Okay, 14.
Is that it? Is that it?